Welcome back to the channel, and this edition of Mr. Richards Teaches is brought to you by the Flow Zone, in which we give props where props are due to teachers around the world. This week it goes out to the ozone layer. When Miss O is in the zone, her students are within thy layer. All right, for our Math 3 Unit 2B.1 review, we will be simplifying rational expressions. Number 1, x squared minus 9x plus 14 is set over 7 minus x. That doesn't look to be in a standard form. So number 1 says to rewrite the denominator. Let's zoom on in. Let's highlight that denominator of 7 minus x. When we rewrite this, we will also rewrite the numerator as well. All right, so this is going to equal x squared minus 9x plus 14. And yes, we will set that over, not 7 minus x. But what we will do, we will throw a negative, and then we will set it over x minus 7. And the reason this works, take a look. Negative 1 times x would give us our negative x, and negative 1 times negative 7 would give us our positive 7. All right, step 2 simply says to factor the quadratic. All right, so taking a look at this, well, we have our quadratic here, x squared minus 9x plus 14. I'm just going to highlight that in red across, and then we will begin to think of our factors that of positive 14, that when multiplied get us to 14, yes, factors, and when added or combined get us to negative 9. Truly, I can only think of x minus 7 and x minus 2. And then we will set that over that negative with x minus 7. All right, so we know that that equals that. And on to step 3, it says to cancel. Well, what can we cancel? Well, we're looking for factors that we can cancel out. And yes, x minus 7 can cancel out as well as the x minus 7. So this right here is going to equal x minus 2 over negative 1. But step 4 says to multiply the numerator and denominator by negative or negative 1 to cancel. All right, because we don't want a negative denominator. We want it to be positive and set over 1. So what we'll do is we're going to take this, we're going to multiply it by a negative, but what we do to the denominator, we will also do to the numerator here. All right, this is going to give us equal to, well, negative times x gives us negative x, and then that negative or negative 1 times negative 2 gives us a positive 2, and then we will set that over. Well, a negative times a negative 1 gives us a positive 1, which is actually equal to negative x plus 2. Go ahead and box your answer. Move forward to number 2. All right, we have x over x plus 5 times 3x. We need to set that 3x. What can we write it as a fraction? Yes, great job. 3x over 1. Rewrite with denominator. And again, we're simply just going to do that. I will highlight the 3x just to show you that later when we rewrite it, what it's equal to. All right, so we have x over x plus 5 times 3x over 1. From here it says just multiply across. Okay, cool. Well, let's see what this equals. We're going to do this just so we can do that later. And yes, does it really matter? No, it doesn't. All right, x times 3x gives us 3x squared. And x plus 5, well, times 1, that's just going to stay the same. So x plus 5, go ahead and box your answer. All right, moving forward to number 3, trying to do this effectively and efficiently as possible. Rewrite numerator of second fraction in standard form and factor quadratic. All right, I went back to this looking at my notes, and I forgot to rewrite in standard form originally, so I added it last minute, so I didn't leave a whole ton of space. So I'm actually going to highlight that. I'm actually going to highlight the quadratic that we're factoring out as well. And the first thing I'm going to do, I'm going to show you how we can rewrite this 4x squared minus 24x minus 64. All right, so let's go ahead and factor that out. All right, so our 4x squared minus 24x minus 64. All right, the first thing we would like to do is, well, see if there's a greatest common factor. Well, 64 divided by 4 is 16, and 24 divided by 4 is 6. So 4 numerically is our greatest common factor. All right, so right here I'm going to put, first thing we're going to do, actually, let me get rid of that and add it over here, is do the GCF. All right, we're going to pull that 4 out. And then 4 divided by 4 is 1, leaving us x squared. All right, negative 24 divided by 4 is negative 6. And negative 64 divided by 4 is negative 16. But we can continue to factor the quadratic further. We just leave our 4 hanging out. Very cool. All right, so now we need the factors of negative 16 that when combined can get us to negative 6. Well, negative 8 times 2 gives us negative 16, and negative 8 plus 2 gives us negative 6. And that's how we're going to write it. From here, we will rewrite the entirety of our rational expression. And here we go. I'm going to do the 4. X minus 8, x plus 2. Beautiful so far. All right, we'll set that over. Our x minus 8. We'll still do the multiplication here, but I'm actually going to flip this to 2x plus 3. We don't have to do a negative because everything's positive. Lucky us. Man, that 3 looks terrible. And then we'll set that over our x plus 2. All right, so we factor the quadratic. Now we have to cancel. All right, so let's go ahead and cancel some things out here. Well, x minus 8 we can cancel. X minus 8 we can cancel. X plus 2 we can cancel. And x plus 2 we can cancel. All right, so technically this is giving us 4 over 1 times 2x plus 3 over 1. All right, and then we're just simply going to multiply across. I'm actually just going to put this in parentheses to show you. 4 times 2x is going to give us 8x. 4 times 3 is 12, so we'll do plus 12. And if we know that 1 times 1 is 1, we're simply just setting it over 1. We don't need to set it over 1. We can simply box our answer. I hope that we learned that from number. Carrying on to number 4, we have x squared plus 5 over x minus 4 minus, okay. So adding or subtracting looks a little different. X minus 7 over x plus 2. Let's take a look at step number 1. Set least common denominator. What we add to the denominator of one fraction for least common denominator, we must add to the numerator as well. This balances the numerator. And when we are adding or subtracting rational expressions, it's just like our basics that we learned in grade school. We have to have that least common denominator. Well, let's take a look. In order to find that, we're simply just going to take our x minus 4, sorry about that, highlighter, did not mean to, and our x plus 2. All right, so our LCD, not the sound system, our least common denominator is equal to x minus 4 and x plus 2. All right, we need to rewrite this. And I'm only going to do it in black of the original and pink to what we have to add for each. All right, so I'm going to take our x squared plus 5 in our numerator. I'm going to leave this just a little lengthy for a minute because our x minus 4 is also within that. However, what's missing from the denominator? Yes, it is. It's x plus 2. And in order to balance the numerator, we must also add the x plus 2 there as well. And I'm actually going to go ahead and just throw these in parentheses for now. Bring down our subtraction. We need to do the exact same thing. So I'm going to take that numerator of x minus 7. It's going to make it a little longer because, yes, we may have to add something there. All right, I'm actually going to write the x plus 2 over here. That comes with it, only because we want to keep that alike. I just want to have that for viewers to see. All right, so x minus 4 is what this denominator is missing. And our numerator needs to balance that as well if we add it. So we need to put the x minus 4 there. I'll go ahead and set these in parentheses. All right, so for number 2, it says expand numerators by multiplying / distributing. All right, so we need to expand upon our numerators. Well, x squared times x is going to give us, yes, x cubed. X squared times 2 is going to give us, yes, so plus 2 x squared. Well, 5 times x is going to give us a 5x, and 5 times 2 is going to give us a 10. All right, we're going to bring down our minus symbol with it here. All right, we're still going to subtract here. However, we will set it over our denominator. And this I'll simply just copy because I can real quick if possible and drop it below. Perfect. Again, denominators stay the same, just like working with whole numbers when we are adding and subtracting fractions. We will do the exact same thing over here. All right, well, x times x is, yes, x squared. X times negative 4 is negative 4x. Great job. Negative 7 times x is minus 7x. And negative 7 times negative 4 is a positive 28. We will go ahead and again set that over our denominator. So I'm going to copy and paste that again just because I can with Notability. Saves us a little bit on the writing. All right, we're going to go ahead and then it says, what does it say for step 3? Oh, distribute the negative so we can combine like terms. No big deal. All right, so let me go ahead and highlight the negative. Yes, that right there. We need to distribute to the numerator. All right, what I'm going to do first is just simply copy and paste what we have here down below. If you're working at home, you may have to write that out. No big deal. All right, then I will distribute. Negative 1 times x squared just becomes negative x squared. And yes, Mr. Richards, can't we just flip the signs? That's exactly what we're doing. You see how negative 4x becomes positive 4x and negative 7x becomes positive 7x and positive 28 becomes negative 28? Wonderful. All right, and again, we'll set that over our common denominator. From here, it says step 4, combine like terms. I'm actually going to draw a little bridge in brown connecting that. It was supposed to connect, but it's not perfect. However, I'm going to highlight that in brown just so we can see our bridge to connect and combine like terms. Woo! Not bad. Our x cubed, I'm going to put a check mark on. All right. Not a great check mark. Let's make that a better check mark, all right? That doesn't even look that great either. However, I can't combine it with anything. I don't see anything to the x to the third power. So I'm going to set that equal to, I'm just going to bring down my x cubed, and then I'm going to circle my plus 2x squared. Anything else? X squared? Yes, we have a negative x squared. Anything else? No, I don't see anything else. So that will be plus x squared because 2 minus the 1. All right, I will box my 5x. Anything we can combine that 5x with? Great call. 4x and 7x. 5 plus 4 is 9. 9 plus 7 gives us a sweet 16x. And 10 minus 28, or 10 I'll star, the negative 28 I'll star. We can combine. 10 minus 28 gives us negative 18. We will simply, yes, I know I say simply, set that over our least common denominator and go ahead and box our answer. All right, so a little longer, but not bad. Truly, not bad. Oh my goodness. Adding and subtracting, we need to find that least common denominator. All right, so again, step 1, set least common denominator. What we add to the denominator of one fraction for LCD, we must add to the numerator as well to keep that Libra-type balance. All right, so let's go ahead and take a look at that. And we will write our LCD the exact same way. LCD equals, well, 6x and x plus 2. Now we will rewrite this and begin from there. All right, so what is already given to us will stay in black. What's added to either the numerator or denominator of both fractions here will be in pink, just so you can have that visual representation. All right, so this is equal to x squared minus 7. And again, remember to make that a little longer. Our 6x here. And yes, you can go ahead and actually set these in parentheses if you'd like, just so you have it. But what's missing from that denominator? Well, we have the 6x, but we don't have the x plus 2. Wonderful work. And what we do to the denominator, we must do to the numerator to balance it. All right, we will add that too, and let's do it again. Our 4x is already there. However, I am going to make that second in line just like I did before. And what else is given to us? Well, the x plus 2 is given to us. All right, and then in front, what's missing from that x plus 2 is the 6x. And again, what we do to the denominator, we must do to the numerator. From here, again, expand numerators by multiplying / distributing. So we're doing the exact same thing. Wonderful. X squared times x gives us x cubed. Goodness, my 3's have always been terrible. X squared times 2 will give us 2x squared. Then we have negative 7 times x giving us minus 7x, and negative 7 times 2 giving us negative 14. Plus, and I am going to copy and paste my denominator because I can. Let me draw a line here. All right. Now, if you do get my hard copies of these, yes, you know they're minted in gold, and you can see how sloppy my writing is when I'm trying to go over this fast. However, the reviews are always printed and minted the way I like to see them. Yes, I know. 6x times 4x gives us, what does that give us? Yes, great job. Mr. Richard's favorite math game, 24. Don't forget the x squared. And what are we doing with that? We are... Sorry, I just want to put that equal to blue, setting that over. Again, that common denominator. I'm going to copy. I'm going to paste and set it there. Wonderful. Step 3 says to combine like terms. Do we have to distribute a negative? No, because this time we're adding, and a positive one would not affect anything. So what we're going to do is just simply combine like terms, and I am going to add in our bridge here. Let's bridge it. Boom. Let's go ahead and highlight it just so we can see the bridge and we can combine like terms. Wonderful. X cubed. I'm going to check it. Are there anything with an x to the third power? I don't see any other terms built that way, so let's set that equal to x to the third power, x cubed. I will, didn't like that, the way it zoomed auto. Plus 2x squared. Any other terms with an x squared? Yes, there's a 24x squared. And they do combine on my birthday, 26x squared. Wonderful. I'm going to box my negative 7x. Anybody home with negative 7x? Nobody home. Go ahead and drop it. I'll star my negative 14. Nothing to combine with. Minus 14. We will set that over our common denominator. That will be copied and pasted. And then we will go ahead and we will box our answer. All right, for number 6, let's move forward. It's asking us to rewrite. All right, keep first fraction, change sign from division to multiplication, flip second fraction. I know the ozone layer, Miss Oler, in this week played us a hip-hop jam that was simply like keep, change, flip. I'm going to keep, change, and flip. Yes, I know, very turd-like by Mr. Richards right there. All right, but here we go. All right, we need to rewrite this first. All right, so it said to keep the first fraction as is. So I'm just going to rewrite it, x squared minus 16. We're going to put that over our x plus 5. Then it said to change the sign from division to multiplication. Let's do that. And then flip our other fraction. So the x will go on top, and then that will be set over x plus 4. All right, so step 2, it says factor first fraction numerator by difference of squares. All right, we really only want to be factoring things when we can cancel afterwards, and I'll tell you what, we can definitely cancel after this one. So let's go ahead and take a look at it. And yes, I think your test might be to design something similar, so keep an eye out for that difference of squares. All right, I'm just going to show the step in which we completed here. Let's continue to rewrite things. And then from here, it says the step 3, well, we can cancel out factors here. And when multiplying, we can go top to bottom and diagonal, not just top to bottom when adding or subtracting. Our x plus 4 will cancel. Our x plus 4 will cancel. We'll rewrite this as 1 over x plus 5 times x over 1. And essentially, oh, Mr. Richards, you forgot something. Yes, you did. I knew I did. I knew it just didn't look right to me. All right, before I go over this rewriting, let me back this up a hair. All right, let's set this equal to. We're just going to write what's left. Our x minus 4, Mr. Richards, how'd you not see that? I don't know. I must have been wearing sunglasses in the basement studio. Over x plus 5 times our x over 1 because, well, it's the denominator that canceled out, so it's just simply going to be our x over 1. We've canceled. From here, now we can simply multiply across. Yes, thank you. You guys are the best. X times x is x squared. Negative 4 times x gives us negative 4x. We'll set that over. Do we really need to multiply x plus 5 over 1? No, because it stays the exact same as x plus 5. We can go ahead now and we can box our answer. All right, moving forward to number 7. All right, we're going to factor. We will have to do it 2 steps here for our quadratic, cancel, multiply across. So let's go ahead and just show that representation here. So our 2x squared minus 14x plus 24, let me zoom in tight. All right, that's equal to, is x greater than 1? It sure is. It has a 2. And is everything divisible by 2? Well, they're even numbers, so they certainly are. So we're going to pull a 2 out. All right, well, 2x squared divided by 2 is going to leave us just our x squared. All right, negative 14x divided by 2 will leave us negative 7x. And 24 divided by 2 will leave us 12. But can we factor that quadratic any further? Well, we would need 2 numbers that when multiplied are equal to 12, but when added or combined get us to negative 7. 6 and 2 don't work. That would give us 8. Can we use 4 and 3? We certainly can. All right, remember we have to do x minus 4 and then x minus 3. My goodness, wow, I really am bad at those 3's occasionally. All right, because negative 4 times negative 3 gives us our 12, and negative 4 minus 3, or added and combined, gives us our negative 7. All right, everything else we're just going to rewrite. So x plus 8 over x minus 4 times 2, open your parenthesis, x minus 4, open parenthesis, x minus 3, close it. Set that over our x minus 3, that's there. And remember, when we're canceling now for step 2, we can cancel factors top to bottom and also diagonal. All right, so let's take a look. Anything that cancels top to bottom here, no, but top to bottom that's on a diagonal, we can. Anything top to bottom here, we certainly can. Wonderful. Let's set that equal to, and again, it's x plus 8. That's what's left. We can set that over that imaginary 1 if you'd like. You don't have to. It's just to have that representation there. What's left here is a 2. All right, and then we don't have anything on the bottom again, so we could do it over the 1. You could have simply just wrote it as x plus 8 times 2. And then from here, we just simply multiply across or distribute. All right, so let's just do this, and then we'll take our x times 2. That's going to equal 2x. We will do our 8 times 2. That's going to give us a 16. Do we need to set it over 1? No, we do not. We can simply just box our answer. And then we'll push forward to number 8. So this review's not going as rough as I thought it would, but we're still trying our best. All right, so step 1 says to factor. We're going to factor a couple of quadratics here. All right, x squared plus 3x minus 10, x squared plus 8x plus 15. They both can be factored. I'm just going to highlight them both just so you can see that when we do it. And I try to keep that a little bit. There we go. All right, let's zoom in on tight here. All right, let's factor x squared plus 3x minus 10. We need the factors of negative 10. So when multiplied, get us to negative 10. And when combined, get us to plus 3. Well, 1 and 10 aren't going to work. How about a 5 and a negative 2? So x plus 5 times x minus 2 is equal to our quadratic right there. And then we will set that over. Let's find the factors of x squared plus 8x plus 15. Well, 1 and 15 won't get us to 8, but 5 and 3 will. So x plus 5 times x plus 3, that factors 2. All right, let's do our plus there. Ooh, we're adding these eventually? Oh, goodness, please. However, let's just write our 5x over our x plus 3. All right, remember that when we add and subtract, we cannot look for factors diagonally. We can only go up and down. Well, step 2 says to cancel. All right, and up and down or vertically, we can do x plus 5, get rid of our x plus 5. Ooh, great news though. We don't have to do a least common denominator because, take a look, x plus 3 and x plus 3, are they the same? Yes, that is going to be our least common denominator. So let's just go ahead and write what's left. We have our x minus 2 here over x plus 3. You can put in parentheses. You don't need to here. Plus, let's go ahead and rewrite this in green. 5x over our x plus 3. All right, from here, we're simply going to combine like terms, all right? Because we're not multiplying anything, we're adding. All right, so let's go ahead and take a look at, we have an x. I'm going to circle it. Can I combine that with anything? Yes, I can combine it with 5x. And 1x plus 5x gives us how many x? Great job, 6x. Our negative 2, can we combine that with anything? Certainly can't. There's nothing there left to. And we do have our common denominator of x plus 3. Go ahead and put that over. And from here, we will simply box our answer. All right, moving forward to number 9, we will have to factor, cancel, distribute the negative, so we can CLT and combine like terms. Not bad. So it's the exact same thing we did above. There's just one added step to it. Well, let's take a look. All right. Our x squared plus 12x plus 36. What are the factors of 36? So when multiplied, get us to 36, but when combined, get us to 12. 1 and 36 don't work. Let's see, 12 and 3 doesn't work. 4 and 9 doesn't work. But 6 and 6 works because x plus 6. And then we'll do x plus 6. Well, 6 times 6 gives us our 36, and 6 plus 6 gives us our 12. All right. Then we need to factor our other quadratic here on the bottom. Did not mean for that. Let me back that up a hair. All right. So now we need the factors of negative 66. So when multiplied, but give us negative 66, but when added or combined, get us to negative 5. 1 and 66, 2 and 33, 3 and 22. I'm not going to go through them all, but I will just get straight to the point with this one and go with negative 11. So x minus 11, and then we have x plus 6. Because negative 11 times 6 gives us negative 66, and negative 11 plus 6 gives us negative 5. I'm going to rewrite my subtraction symbol there. I'm going to set it over 2x minus 5 over x minus 11. Again, we can only cancel up and down. We can't go diagonal because we're not multiplying. We can only go up and down because we're subtracting. So let's take a look at what we can cancel. Start here, x plus 6 and x plus 6. Can't combine anything or cancel anything there, so we can't cancel anything there. So let's just go ahead and rewrite this all in green of what's left. We have our x plus 6 over our x minus 11. Bring down our subtraction symbol. Keep that in black because nothing changed. Or actually, no, rewrite that entirety in green. Over x minus 11 All right, as you can see, we do have that same common denominator of x minus 11, so we don't have to do the things we did with numbers 2 and 3. So it asks us to now distribute the negatives so we can combine like terms. And again, we have to do what we did before. We have to take that negative 1. All right, so what I'm going to do is I'm just going to copy and... do I copy and paste here? Let me just rewrite this top in orange. All right, x, or our first fraction, x plus 6. All right, I'm going to set that over our common denominator of x minus 11. Then I will distribute our negative 1. Again, it's just simply flipping signs. Negative 1 times negative 5 gives us plus 5. And then setting that over our common denominator of x minus 11. All right, now it was still subtracting, but we got rid of the subtraction, so now it just says to combine like terms. I'm going to do our bridge in brown. I'll also highlight that so you can just simply see it, that we are combining like terms at this stage in the game. All right, so x, what can we combine that with? Oh, negative 2x. And 1x minus 2x leaves us a negative x. Beautiful. 6 a box plus 5 a box, so plus 11. Wonderful. We can set that over our common denominator of x minus 11. All right. Oh, and what do we have here? Well, guess what? Is negative x and x an opposite? They are, and we divide a negative by a positive and then a positive by a negative. Well, they'll both be negative. We can simply write our answer as negative 1. Go ahead and box your answer. All right, moving forward to number 10. Not so bad so far. Let me switch my highlighters here. All right, we need to rewrite, keep first fraction, change sign from division to multiplication, flip the second fraction. All right, I think I missed something here too. Our x plus 4, no, that's perfect. All right, my bad. It must have been on a different one. Let me take a look, though. So it just says to rewrite and flip x squared minus 15x plus 56. We'll set that over our 4x plus 16. Our division, we change the sign to multiplication, and then we flip our second fraction. So the x plus 4 will go on top as our numerator, and the denominator then becomes 3x, sorry, not written well, minus 21. Perfect. All right, from here we have to factor a few things. And by a few, yes, I do mean 3. All right, first thing we'll do is factor our quadratic of x squared minus 15x plus 56. All right, so we're looking for the factors of 56. When multiplied, give us 56, but when added and combined, give us negative 15. All right, well, x minus 8 times x minus 7. Negative 8 times negative 7 give us 56, and negative 8 minus 7, or negative 8 plus negative 7, give us negative 15. All right, that quadratic's factored. Take a look at the denominator, all right? We can factor this by greatest common factor, so 4x plus 16 is what we have here. I'm going to highlight that for us just so we can see it below. All right, well, 16 divided by 4 gives us a whole number of 4, so 4 is going to be our greatest common factor. We're going to open up a parenthesis. 4x divided by 4 leaves us just 1x, and 16 divided by 4 simply leaves us 4. Let's bring over our multiplication. Our x plus 4, nothing we can do there. But then we're going to take a look at 3x minus 21. Can we factor that? Yes, we can, again, by greatest common factor. All right, so we have a 3. 3x divided by 3 gives us 1x. Negative 21 divided by 3 gives us minus 7. All right, so step 2's done. Step 3, we need to cancel. All right, and again, we're multiplying, so we can go up, down, and diagonal. All right, so our x minus 8, can we cancel it with anything? No. How about x minus 7? If we go diagonal, we certainly can. Now, how about our x plus 4? If we go diagonal, we certainly can. And what is left? Well, on top you have x minus 8, and on the bottom you have a 4 times what would be essentially a 1 over a 3, because there's nobody up top giving us that 1. What's on the bottom left over is a 3. And if we simply multiply across, well, x minus 8 times 1 staying the same. So x minus 8 over, ooh, did not mean for that, our 4 times 3, which is 12, giving us x minus 8 over 12. Go ahead and box your answer for number 11. Might be a bonus, I'm not too sure. All right, provided the width of x squared plus 7x minus 18 over x and a length of 3x squared plus 3x over 9 plus x for a rectangle, find the area and perimeter. All right, this might be like the most challenging of them all, only because, well, is it really that challenging? No, but does it take a little more effort? Some do more than others, but that's okay. All right, because if we're living in Mr. Kintz's world here, all right, math doesn't get more challenging as we get older. It just becomes longer as we level up. All right, but the arithmetic is the same. So let's take a look. Let's just go ahead and write this out. X squared plus 7x minus 18 over x. All right, we're going to multiply because area is length times width times 3x squared plus 3x over 9 plus x. Are we good so far? I hope so. Wonderful. What we need to do though, number 2. Well, I guess really number 1, I just forgot to write it, but we just wrote it, no big deal. All right, it says the factor. I'm going to factor the quadratic here and the quadratic only. Only because if we did factor by greatest common factor here, well, nothing's really going to cancel. I know, little unfortunate. No big deal, though. All right, give me the factors of negative 18. That when multiplied, give us a negative 18. And when combined, give us 7. Did I hear a 9 minus 2? Yes, I did. X plus 9, x minus 2. We'll set that over x times 3x squared plus 3x over 9 plus x. Wonderful. We need to cancel, and again, we're multiplying, so we can cancel up and down or diagonal. X plus 9, we can cancel with 9 plus x, which is also equal to x plus 9. Mr. Richards, you forgot to rewrite it. I did. I'm terribly sorry about that, but nothing changes because it's positive. So x plus 9 is equal to 9 plus x, and rewritten, we would have just wrote it as x plus 9. All right, so this is going to be set equal to, we're going to take our x minus 2 over x times 3x squared plus 3x over 1. We're going to multiply across and then set it equal. So x times 3x squared gives us, wonderful work, 3x cubed or 3x to the third power. X times 3x gives us wonderful work again, 3x squared. Negative 2 times 3x squared gives us a negative 6x squared, and negative 2 times 3x gives us a negative 6x, and x times 1 is still just x. All right, from here we can simply combine like terms. I'll put a check mark over our 3x cubed. Anything else, x to the third? I don't think so. 3x to the third. Our 3x squared I'm going to circle. Negative 6x squared I'm going to circle. Yes, they can be combined. 3 minus 6 is negative 3. Don't forget your x squared. Minus 6x, we'll box that bad boy. Can't be combined with anything. We'll go ahead and we'll set that over x. Now, when you're looking at your numerator and denominator, is there anything else that we can do? We simply can. We can cancel our x out. All right, I'm going to do that in gray for us. Let's get rid of that, but what we do to the top and bottom, yes, we have to do the same, so that becomes a squared. We'll get rid of this, we'll get rid of this, and then we'll set our answer equal to 3x squared minus 3x minus 6. Go ahead and box your area. And now we will scroll down to get that perimeter. All right, perimeter. Number 1, set least common denominator. What we add to the denominator of one fraction for LCD, we must add to the numerator as well, again, to keep that balance because we are adding this time. All right, let's get our LCD out of the way. We know that we can take our denominator from fraction 1, and we can take our denominator from fraction 2 and make that our least common denominator. All right, and again, what's already written in black, I'll keep in black. And then what's added to both the denominator and the numerator for that balance, I will put in pink. So let's actually set this equal to x squared plus 7x minus 18. And make that just a little longer. And then we will set that over our x. All right, now what's missing from the denominator from our LCD? Well, if it has the x, it's missing again that x plus 9. Now we have our common denominator written, and for the balance, we also have to do that to the numerator. All right, then we will put our plus, and I'll simply write our 3x squared plus 3x. And again, for continuity, I kind of like to write the denominator the exact same way so there's no confusion. All right, and that was given to us in black. That denominator is missing simply just the x. And again, we'll do that to the numerator. All right, step 2, expand numerators by distributing, which is just our multiplication. Let's go ahead and do that. So we'll set this equal to x squared times x gives us x cubed. X squared times 9 gives us 9x squared. 7x times x will give us 7x squared. 7x times 9 will give us 63x. Negative 18 times x will give us negative 18x. And negative 18 times 9 will give us negative 162. All right, we'll set that over our common denominator. Copy, paste. Oh, I'll also do that with our plus symbol. Copy, paste. As we still need to do our distributing here. All right, x times 3x squared will give us 3x cubed. X times 3x will give us 3x squared. And again, we will set that over our common denominator. Now from here, sorry, just wanted to write that. Didn't get that, and I forgot to write that there. All right. Then from here, we will simply, step 3, combine like terms. We will do our bridge in brown. I will also highlight that as well. And then we will simply combine our like terms. It's a long one here. X cubed. Anything else with an x cubed? Yes, there is. 3x cubed, 1x cubed plus 3x cubed gives us 4x cubed. Circle our 9x squared. Anything else? 9x squared. I do see a 7x squared. And if I go down the number line, we have a 3x squared. Well, 9 plus 7 is 16, plus 3 is 19. Don't forget your x squared. All right, I will box my 63x. Anything with just an x? Yes, that negative 18x. 63 minus 18 gives us the return Jordan of 45. Don't forget the x. I'll put a star over our negative 162, which cannot be combined with anything. I'll go ahead and write that. Keep it over our common denominator. Now, we've added 2 sides, but we have not added all 4 sides. What can we do? We can multiply our numerator by 2, giving us, yes, 2 times 4x cubed equals 8x cubed. 2 times 19x squared plus 38x squared. 2 times 45x plus 90x. And 2 times negative 162 is negative 324. Set that over your x times x plus 9. You have a perimeter. Go ahead and box your answer. Call it a review. Dominate, crush, beast this thing. Let's go.